Welcome to our channel. Today we're diving into the mesmerizing world of Saturn's rings. From the moment we pointed our first telescopes at the heavens, Saturn's rings have captivated us. Join me as we journey to this gas giant and unravel the mysteries of its most iconic feature. Our story begins in 1610 with a curious mind named Galileo Galilei, a man whose insatiable curiosity and groundbreaking ideas would forever change our understanding of the cosmos. Gazing through his rudimentary telescope, Galileo became the first human to observe Saturn's rings, a sight that no one had ever seen before. But alas, his telescope lacked the power to resolve them clearly, leaving him with more questions than answers. To him, they appeared as strange, ear-like appendages flanking the planet, a mystery that would puzzle him for years. Imagine the perplexity he must have felt peering into the unknown and glimpsing something so utterly alien, so different from anything he had ever encountered. It wasn't until 1655 when the Dutch astronomer Christiaan Huygens, armed with a more powerful telescope, finally unveiled the truth. Saturn was adorned not by ears or moons, but by a magnificent system of rings, a revelation that would astonish the world. This discovery marked a turning point in our understanding of the solar system, reshaping our view of the universe. Galileo's initial observations, though limited, ignited a spark of curiosity that would drive astronomers for generations to come, inspiring countless others to look up at the stars and wonder. Now, you might imagine these rings as solid, impenetrable disks, but the reality is far more intricate. Saturn's rings are not monolithic structures, but rather a dazzling mosaic of countless individual particles. These particles, ranging in size from microscopic grains to massive boulders, are composed primarily of water ice with traces of rock and dust. Picture this: sunlight glinting off a sea of ice crystals, stretching across vast distances, a breathtaking cosmic spectacle. The high ice content points towards a formation process involving icy bodies, perhaps shattered moons or captured comets. Imagine a cosmic ballet with countless icy dancers swirling and twirling in the gravitational grip of a giant planet. In the grand cosmic timeline, where billions of years are but a blink, Saturn's rings are surprisingly young. Scientists estimate their age to be around 100 million years old. A mere whisper compared to the 4.5 billion year age of our solar system. To put that into perspective, if the entire history of the Earth were compressed into a single day, Saturn's rings would have formed in the last 3 minutes. Some theories suggest that the rings are the remnants of a shattered moon, torn apart by Saturn's immense gravity. Others propose that they formed from material left over from the formation of Saturn itself. Their relative youth also raises questions about their longevity. Now let's take a closer look at the structure of these magnificent rings. The most prominent rings, visible even with a modest telescope, are the A, B, and C rings. Each possesses its own unique characteristics and mysteries. The A ring, the outermost of the main rings, is characterized by its brightness and intricate structure. It's separated from the B ring by the Cassini division, a prominent gap named after its discoverer, the Italian astronomer Giovanni Cassini. The B ring, the largest and most massive of the rings, is a dazzling spectacle of swirling ice and rock. Then we have the C ring, fainter than its companions, yet no less intriguing. These rings are not perfectly uniform, but are instead adorned with intricate patterns, gaps, and even kinks. As we marvel at the grandeur of Saturn's rings, we are drawn into a mesmerizing dance of celestial mechanics. We can't help but notice the intricate gaps and divisions that punctuate their structure, each telling a story of cosmic forces. These gaps, far from being empty spaces, are a testament to the powerful gravitational forces at play, shaping the rings over eons. One of the most prominent gaps is the aforementioned Cassini division, a striking feature that captures our imagination. This 3,000-mile wide void separates the A and B rings, creating a dramatic division in the ring system. The particles within the Cassini division are being tugged by the gravity of Mimas, one of Saturn's moons, which exerts a significant influence. This gravitational influence creates waves within the rings, much like a boat creates ripples on a pond, adding to the dynamic beauty of the rings. These ripples and waves are a visual representation of the unseen forces at work. Numerous other gaps and ringlets, smaller features within the rings, are also present. These intricate patterns are sculpted by the gravitational pull of these celestial shepherds, each playing its part. It's a delicate cosmic ballet, a testament to the intricate relationship between a giant planet, its rings, and its orbiting moons. This dance of gravity and matter is a beautiful reminder of the complexity and wonder of our universe, a testament to the intricate relationship between a giant planet, its rings, and its orbiting moons, showcasing the harmony of celestial mechanics. Imagine a shepherd guiding their flock, keeping them in line and preventing them from straying. In the cosmic dance of Saturn's rings, certain moons play a similar role, earning them the name shepherd moons. These moons, often small and unassuming, exert a disproportionately large influence on the structure and stability of the rings. One such shepherd is Prometheus, a moon that orbits just inside the F ring, a narrow and faint ring located beyond the A ring. Prometheus's gravity acts like a gravitational dam, keeping the particles of the F ring confined and preventing them from spreading outward. On the opposite side of the F ring, we find Pandora, another shepherd moon, working in tandem with Prometheus to maintain the ring's structure. The discovery of shepherd moons revolutionized our understanding of Saturn's rings. When we see images of Saturn's rings, it's easy to be overwhelmed by their vastness. Stretching for hundreds of thousands of miles, they seem like immense, impenetrable structures. But here's a surprising fact. Despite their immense width, Saturn's rings are incredibly thin. Imagine this. If you could shrink down Saturn to the size of a basketball, its rings would be about the thickness of a sheet of paper. The particles within the rings are constantly colliding with each other, which should cause them to spread out over time. However, the gravitational pull of Saturn keeps them confined to a relatively narrow plane. The origin of Saturn's rings is a question that has captivated astronomers for centuries. These rings, visible even through small telescopes, have sparked curiosity and wonder. How did these majestic structures, composed of countless icy particles, come to be? What cosmic events led to their formation? The answer, like many things in the universe, remains shrouded in mystery. Despite advances in technology and space exploration, the true origin of Saturn's rings eludes us. One prevailing theory suggests that the rings are the remnants of a shattered moon. This moon, once orbiting Saturn, met a catastrophic end. Imagine a wayward moon, venturing too close to Saturn's immense gravitational grip, only to be torn apart by tidal forces. The immense gravitational forces of Saturn would have ripped it apart. The fragments of this shattered moon, unable to escape Saturn's pull, would have settled into orbit, eventually forming the rings we see today. These icy particles, over time, coalesced into the stunning rings. Another theory proposes that the rings are primordial, remnants of the material that formed Saturn itself. This material, left over from the planet's formation, could have formed the rings. While we haven't definitively solved the mystery of their origin, each theory offers a tantalizing glimpse into the violent and chaotic history of our solar system. The story of Saturn's rings continues to evolve as we learn more about the cosmos. As Saturn embarks on its leisurely 29.5-year journey around the Sun, we Earth-bound observers are treated to a captivating celestial dance, the seasonal changes of Saturn's rings. Because Saturn's axis is tilted, just like Earth's, its rings are not always face-on from our perspective. Over the course of Saturn's orbit, our view of the rings changes, offering us a mesmerizing spectacle of shifting perspectives. When Saturn's rings are tilted at their maximum towards Earth, we are granted a breathtaking view of their full expanse. However, as Saturn continues its celestial journey, its rings gradually appear to close, appearing thinner and thinner, until they are edge-on to us. During this edge-on orientation, which occurs approximately every 15 years, the rings seem to vanish entirely, their thinness rendering them practically invisible from Earth. In the vast expanse of the cosmos, even the most awe-inspiring structures are subject to the relentless march of time. And so it is with Saturn's rings, those majestic rings of ice and rock that have captivated us for centuries. While they may seem eternal, these rings are, in cosmic terms, relatively young and ephemeral. Astronomers estimate that they could disappear within the next 100 million years, a mere blink in the cosmic timescale. One significant factor is the constant bombardment of the rings by micrometeoroids and solar wind particles. These impacts, though tiny, gradually erode the rings over time, sending particles spiraling inwards towards Saturn. The same gravitational forces that confine the rings also cause particles to slowly drift inward towards the planet. Thanks for watching. If you enjoyed learning about Saturn's rings, don't forget to like, subscribe, and hit the bell icon for more fascinating space facts. See you next time. As we conclude our exploration of Saturn's rings, we are left with a profound sense of awe and wonder. These celestial wonders, a testament to the beauty and complexity of our universe, continue to captivate our imagination and inspire us to unravel the mysteries of the cosmos.